This video focuses on one big convoluted question from a DSE paper. It features several things. This is an application of differentiation, and as you can see from part A, it's a transformation of a natural log function. And then later on, we're going to be doing some description on a trend, and then using some global or local extremum. The function of n is the monthly sales volume in 1,000 copies of an online game. Okay, and it's modeled by this function here in terms of t. And h and k are some constants. And the first step is we want to express this quantity as a linear function of t. So we start with our original function n, and we want to do something to become this whole thing. So then the first step is to apply the 3,000. And then next is applying the -1 here. Then I apply the ln on both sides, which I could split up into two parts. That gives us this answer. And this is a linear function of t because it's analogous to the mx plus c. So now after we've done the transformation, you see because it's a linear, then we have a straight line, and the slope would be this, and the horizontal intercept, not the vertical intercept, is 2. So how do you find h and k? But if you recognize this as the linear form, and if the slope equals to -0.5 ln 45, so -k actually equals to that, which gives you this k. Now how do you find h? Then you have to make use of this 2, which brings us to here. It's like the x-intercept, right? It's like when x equals to 2, y equals to 0, because that's a horizontal intercept. So we kind of translate this into our own situation here. So now I could plug in all these numbers here to solve for h. So I have ln 45 equals to ln h, and so h equals to 45 and k equals to 0.5 ln 45. So now here's the interesting part and the practical part. We want to describe how the monthly sales volume of the game varies. Okay, so we're talking about the trend in 2018. So what does that mean in terms of algebra? Well, if you look at t is the number of months since the beginning of 2018. So in other words, it's asking you, how is n of t going in this interval for t? Is it increasing or decreasing? And how do we find out? We look at the first derivative, right? So we start off with n of t. Now if you look at this part, it looks disgusting because it has too many things. Maybe we could simplify first before we dive into differentiating. So first step is I want to arrange this a little bit like that. Okay, because I want to put the ln together with the e so that somewhat maybe they could cancel each other. And then when the exponent is a product, I could raise it up like that and put a bracket in here. That's what we've learned before. And so now the 45 comes down. Let me move this back up here. And by index law, we could combine this together. So now it looks much simpler here. Then I could start taking the derivative. Now usually when we take the derivative, we see a fraction here. So using quotient rule is the best. But because this one is just a constant, there's no need to do a quotient rule because it takes more time. So in this case, I'm going to rewrite it like this. So now I take the derivative, -1 to the front, and give this to -1. And then chain rule. Before doing that, I move this to the bottom. Then I deal with this now, which gives us this because the derivative of a to the u is rewriting it times the ln of this constant, and then again the chain rule. And this is just -0.5. And then I'm going to combine this and this together and move this back up here, move this back up here. Now here's a handsome first derivative. But what next? We usually set the first d to equals to 0, and then we find the turning points, right? If you still remember. But actually there are two concerns. First concern is that the first d never equals to 0. If you look at the numerator, all of these three parts cannot equal to 0. So we cannot find the turning points. Moreover, all we care is just within this interval. Now, even if there's a turning point, but if it's outside of this interval, we still don't care about the turning point. So basically, we just need to check whether within this interval is the first d positive or is it negative. Then we're good. So in other words, we must learn how to analyze the sign of a function. In this case, this one. So for example, the denominator is always positive. This constant and this constant, obviously, you can check on calculator, they are both positive. And even this tricky part is an exponential with the base of a when a is greater than 0, not equals to 1. Such exponential function is always greater than 0, and so this is also positive. In other words, the first t is always positive for all real values of t, which of course includes this part, this interval. So I move this up here. And so in 2018, the monthly sales is increasing. And just a recap, the monthly sales of the game, that is talking about the original function n of t right here. Why is this increasing? Because in this period, the first derivative is greater than 0. So here's the last part of the long question. An enhanced edition will be released when the rate of change of the monthly sales volume reaches its maximum. So when exactly will that be released? It's like the Final Fantasy VII remake. You want to release it when it's the best timing. And when is that? It's when the rate of change of the monthly sales reaches maximum. In other words, when the first derivative reaches maximum, okay, rate of change of the sales, that is the first d, not when n reaches maximum, okay, that doesn't make sense. And so you apply first or second derivative test on the first d, okay, not on the original. So it's like one level down compared to what we have always been doing. This is where it gets super messy, okay, but you just have to go through it by using quotient rule. Or you can use product rule as well, but it won't save you much time. So let me first highlight u, v being the bottom part, the derivative of the top part. This would be the u, and this would be the derivative of the bottom part. Then I will look for common factors, for example, this and this, this and this one and this one, and this one and this one, which gives us this. The highlighted are the common factors taken out. And now I move this back up here. Now we can actually combine these two because 1 star minus 2 stars, and this one and the denominator could cancel out. So now finally we've got the second derivative. Now let's go back to our original intention to finding the maximum of the first derivative. Okay, there are two options. First, if you use the first derivative test, then you look at the second derivative. Or if you want to use the second derivative, then you have to find the third derivative and apply on it. Then you might want to die as well if you want to take another derivative, right? So let's stick with the first d test. Set the second d equals to 0. Again, this is very important to learn to analyze the sign of a function. In this case, this whole thing. So when we set the whole thing equals to 0, we disregard the denominator. And these first two parts will never equal to 0, which leaves only this part equals to 0. In other words, 45 to this power equals to 1, which means that the exponent must equal to 0. And so this would be the turning point. So now we start the first derivative test. So then we set up the table using 2 as the boundary. Now be careful, we're looking at the signs of the second d, not these two. So let's try t equals to 1 for this part. So if you look at this part, and this part, they are always positive, no matter what t equals to. And if this is positive, 1 plus this is also positive, and so is the third power, always positive. So it really depends on this part. And when I use calculator, t equals to 1, this whole thing would be negative. So the whole thing, negative equals to positive. And so this part would be positive. And of course, when t equals to 2, this one's 0. And for this interval, I'm just going to pick some obvious number. For example, 1 million, big enough. And when it's a million, this part becomes positive. And positive, negative is just negative. And so when I go up, 0, and goes back down. And so when t equals to 2, n prime of t reaches the maximum value. And that is the rate of change of the sales not the sales, but the rate of change. And because t equals to 2, and so the enhanced edition of the game will be released in February. That's when t equals to 2 of 2018.